I'm making it work. Okay, so again, this is section 4-1, graphing quadratics. We're in a new unit. We're starting off with the standard form of graphing a quadratic. It's actually pretty simple, okay? The only issue is going to be you and your order of operations, okay? To be honest. Like I can see that that's where, a student may get tripped up is order of operations, okay? Y'all know what I mean when I say order of operations? PEMDAS. Y'all remember PEMDAS? P stood for what? Please excuse my dear Aunt Sally. Please excuse my dear Aunt Sally. P was for parentheses. E, multiplication, division, addition, subtraction. You do realize, though, that with multiplication and division and addition and subtraction is whichever one comes first, right? Okay, just want to make sure. So you are going to need that knowledge-based skill for this particular unit, okay? So let's take a look. Go ahead and flip open your graphing quadratics and standard form of quadratic is y equals ax squared plus bx plus c, okay? Where a, b, and c represent some type of coefficient, okay? So a, b, and c, there's some numbers. They can either be positive or they could be negative, all right? Now, the parent function, your most basic quadratic is y equals x squared, okay? And the graph of that, easiest way to graph any function, whether it's a quadratic, a line, cubic function, any type of function, is to make a table, okay? A good old XY table. Do you guys remember doing this maybe back in Algebra 1?
Yeah.
One person, two people, okay? This is how you can graph a function if you ever forget what it looks like, okay? It doesn't hurt to plug in some points for x and then, do it out and figure out what y is. Yes? No. Nice numbers, nice results, okay? So pick a value for x like 0 and we plug it in for x into the function. What's 0 squared? 0. So 0, 0 is a point on our parent function, okay? You can also plug in 1. What's 1 squared?
1.
1. So that's another point, 1, 1. We all know how to plot points, yes? Yep. The shape of every quadratic is called a parabola, okay? That is that shape. That is that U shape, okay? And like I said, it can also look like this. The axis of symmetry. The axis of symmetry is the line that goes straight through the middle of that quadratic. Okay, it creates symmetry. Does everybody know what symmetry is? Like if you were to fold it, the left side would lie directly on top of the right side. Okay, with the quadratic, it's called the axis of symmetry. It's basically an imaginary line that splits the quadratic in half. Okay, so lastly, it's also going to have a vertex. Okay, the vertex is a point on the parabola that's either the lowest point or the highest point on the graph, okay? Let's graph each one of these functions. Make your table, okay? Let's start with number 1. What's a good point to plug in? 0. Hey, why not? Okay, so if I start with 0, 0 squared plus 2, what is that? 2. So 0, 2 is a point on my parabola. What's another point? 1. All righty. What's 1 squared?
1.
Plus 2? 3. Is everybody seeing where we're getting these numbers from?
Yes.
All we're doing is we're plugging them into the original function. What's another point? 2. What's 2 squared?
4.
Plus 2? And you just continue this process, 2, 6. Now, do you think we should plug in 3?
No.
Why not?
It's
It's going to go off the graph, okay? So right now we kind of got a good idea here.
So do you not have to set it up like this?
No, you can. I just don't have the space for all of that. So what I'm going to actually have you guys do next is plug in some negative points, okay? You guys plug in some negative points now and get the rest of this graph, okay? So plug some negative points into the function. What happened when you plugged in -1?
You got 3.
-1, you get 3. What about when you plug in -2? 6. What about when you plugged in, no, I wrote the wrong thing. You said when you plugged in -1, you got what? 3. -2, you got 6. Okay. So we want to plug in -3. Do you notice anything?
It's a pattern.
It's a pattern. It's the same. What do you mean by that? Elaborate.
They're always the same.
It is symmetrical, okay? So the points on the right side are going to match up with the points on the left side, okay? So if you can figure out where the vertex is and you get some points that are on the right side of the vertex, you pretty much just have to kind of copy them over. They're the same distance away from that axis of symmetry. Remember, that goes straight through the vertex, okay? Let's do number 2, okay? I'll do the negatives, you do the positives, but let's start with 0. When I plug in 0,
You get -2.
awesome, 0, -2. When I plug in -1,
You get -1.
get -1. When I plug in -2, 2. Is 3 going to stay on the graph or no? No. Okay. So you guys do the positives now. You guys do the positives. When you plugged in +1, what'd you get? -1. And when you plugged in +2, what'd you get? 2. Yes. It should look like a U. Every single time it should look like a U, and it should be symmetric about some line. That's called the axis of symmetry, okay? So I want you guys, do you guys think you could do number 3 on your own? Yeah. Okay. Impress me. Try number 3 on your own. Let's see how we did. Did you plug in 0? What'd you get? 0. Yes. Did you plug in 1?
Yes. 0.5.
1/2, 0.5. Either one will be acceptable. Now realize that 1/2 is in between what 2 numbers? 0 and 1. So that's exactly where that point should be. Did you plug in 2? You got 2? Okay. Did you plug in 3? 4.5. Okay. It does actually stay on the graph. It is 4.5 or 4.5. So I'm going to go to 4, 1, 2, 3, 4, and then halfway. But I'm pretty sure that 5 is going to, the next one's going to be off.
4 doesn't come off.
4 doesn't come off?
It's 4/8.
Oh, 4/8, okay. 4/8. 1, 2, 3, 4, 5, 6, 7, 8. Oh, okay. Good stuff. Then you got to plug in your negatives. -1. 1/2. -2. 2. -3. 4.5. And -4. 8. Yes. Please make sure yours are looking like U's and not like V's. Okay? Now, purple one kind of looks a little bit like a V, but I'm trying to curve them. So please make sure you guys are curving to make them look like parabolas. All right? Good job. Let's do number 4 together. Okay? If I plug in 0, what do I get? 0. When I plug in 1,
You get 1. It's -1 squared. It's still 1.
Careful.
1 squared and then you put the negative.
Order of operations. That's what I was talking about. This is a negative. x squared, which means this is a negative 1 squared. So order of operations says to square the number, then change the sign. So this should be a negative 1. Because this is basically a negative 1 times x squared. That's pretty much how that's set up. That's why I want to do this one together. Some of y'all using pen. I didn't want you to make a mistake. So when I plug in 2, it's basically I'm squaring 2, then changing the sign. So then it's going to be a negative 4. So I'm at 1, negative 1, 2, negative 4. 3 is not going to fit? It doesn't? No? Okay. So when I go to plug in my negatives, this is how it's set up. So it's still going to be a negative 1. When I go to plug in a negative 2, remember you apply your exponent first and then you change the sign. So then it's going to be negative. If it's a negative, it's going to go down compared to 1, 2, and 3, which were all positive. Okay? That is true. If that a term, if that coefficient in front of that x squared is negative, it's always going to point down. All right. Let's flip over. Let's look at graphing quadratics. Now, this quadratic and the ones in this section are different from those very simple basic ones, okay? These are ones that are fully in standard form. They have an A term, they have a B, and they have a C term. Does everybody see that from the standard form? Does everybody see that? What's A in this problem? It's 1. It's the number that's in front of your x squared. What's B? Negative 2. What's C? Negative 3. Okay? If we have to find the axis of symmetry, okay? If it asks us to find the axis of symmetry, we got to use that formula from the last flap. Do you guys remember what it was? If you don't remember, you can always flip back.
Negative b over 2a.
Negative b over 2a. Okay? Not asking the hard questions here. Okay? Hopefully you wrote it down. You do need that formula. That's how you find the axis of symmetry, negative b over 2a. So for this problem, it's negative b. What you guys say b was again? So you have a negative 2 over 2. What was a? 1. Becomes 2 over 2, which is 1. The axis of symmetry is at 1. Okay? So that imaginary line is at a positive 1 crossing your x-axis, and it's always your x-axis. It's always vertical. Okay? Questions up to here. Your vertex lies on that line. Okay? So unlike those first 5 graphs that we've already graphed that had a vertex somewhere, on the y-axis, this one's not going to be on the y-axis. Okay? To actually find where your vertex is and to help you with your table, okay, the axis of symmetry is always the x coordinate of your vertex. To find the y coordinate, you plug it in to the original function. You plug it into the original function. So, since the function was x squared minus 2x minus 3, I'm going to plug 1 in for every x of that original equation. I'm doing this is because I'm trying to find the y coordinate of my vertex. So 1 squared is 1. 2 times 1 is 2. Then I still have that minus 3. What's 1 minus 2 minus 3? Negative 4. Okay? So the vertex of this quadratic is going to be at 1, negative 4. So that point 1, negative 4 is the vertex of your quadratic. So to find the vertex of your quadratic, you're going to find the axis of symmetry using negative b over 2a. And then you're going to take that value and plug it into the original function. That is your x and y coordinate of your vertex. Does everybody understand? If you don't, you need to say something so that way I can try to, reword it. All right? So when I go to making my table, use that line axis of symmetry as a reference. You already know that at 1, it's at -4. What would be some other good points to plug in? 2, 3. Because those are on the right side of that axis of symmetry. They're going to be on the right side of that quadratic. So that means I'm going to plug 2 back into my original function for both x's. Okay? What's 2 squared? 4. Okay? Here, I'll write it out over here because I don't have the space on my thing. 2 squared is 4. Minus, what's 2 times 2?
4.
Then I had that -3. What's 4 minus 4 minus 3? -3. That is another point on your quadratic. Let's plug in 3. What's 3 squared?
9.
2 times 3?
6.
Minus 3. What's that?
That's
0. So that's another point. 3, 0. All right? You only need a few points on the right side, a few points on the left side to draw your quadratic. We won't go no more, but you should get an idea of how this quadratic goes. Okay? What will be some good points to plug in for the left side? -2. -3, all the way over here. Remember, I started at 1. 0 will be good. -1. Then maybe -2. But since this is symmetric, the point that's over here is going to be the same distance away from the axis of symmetry as this point on this side. So everybody see that? So when I plug in 0, I'm going to get -3 because they're symmetric. They're the same distance on each side of that axis of symmetry. When I plug in -1, I'm going to get 0 because it's the same distance that this point was away from the axis of symmetry. Does everybody see that? If you don't, or if you forget that key fact about a quadratic, you can always just plug in points. But this makes things a little bit quicker. If you can get the right side, you just duplicate it over to get the left side. Does that make sense? Are you sure?
And it's the axis of symmetry is your new line, right?
Yes, it's always that symmetric line. Mm-hmm. And you always find it when you do -b over 2a. And it's always the x coordinate of your vertex. All right? I want you guys to do number 2 and number 3. Find your axis of symmetry. Then figure out what the vertex is from there. Then graph the function. If you have questions, please ask. Okay, so for these, again, find your axis of symmetry and then plug that in to find your vertex, because that will be your starting point for you to make your table and graph from there. Okay? So, axis of symmetry, that is the formula, -b over 2a. So, what's b in this problem? -6. This is a -6 over 2 times a. What's a?
1.
So 1. So I have 6 over 2, which is 3. My axis of symmetry is 3. That means my vertex lies somewhere on that line. How do you find it? Plug 3 back into the original equation. So that's going to be 3 squared minus 6 times 3 plus 4. What was that?
9.
Not.
The answer?
Yeah, final answer.
-5.
-5?
Yeah.
Should be -5. So my vertex is at 3, -5. And even though it doesn't ask you this, is this parabola going to point up or is it going to point down? It's going to point up because that A is positive. So it's going to go up. So now we can make our table and now we can graph. What are going to be some good points to plug in?
3, 4, and 5.
We already kind of have 3, don't we?
3, 4. 1, 2, 4, 5.
We can do 1, 2, 4, 5. I'm going to kind of go an easier route. I'm just going to plug in 4 and 5. Why can't I just plug in 4 and 5?
Because you don't tell you the other opposite.
I can just do the opposite side. So I'm going to plug in 4. When I plug in 4, what do I get?
-4.
-4? Okay. 4, -4. And when I plug in 5, I get -1. Did 6 fit for anybody who plugged in 6? Yes, it's 4. It's 4. All right. So that means that if I plugged in 2, I should get -4. For those who plugged in 2, did you get -4? And if I plug in 1, I should get -1. For those who plugged in 1, did you get -1?
Yes.
And for those who plugged in 0, you should have gotten +4. So then this is my quadratic. This is my graph of my parabola. Questions? Okay? What was my axis of symmetry in number 3?
3.
It was 3. That's a -b over 2a. What was a in this problem?
-1.
Which means that my graph should point down. So another one at 3. I have to find my vertex, so I'm going to plug in 3 into the original equation.
0.
It's what? 0. So I have 3, 0 as a vertex. And now,
4 and 5.
use 4 and 5. Okay. When I plug in 4,
-1.
when I plug in 5, so then I can just copy them over onto the other side. Questions on graphing quadratics when they're in the standard form? Okay. Now it is time to solve quadratics through graphing. We kind of did this already with factoring back in chapter 2, unit 2. Factoring was one way to solve a quadratic. You can also solve them by graphing. The solutions are the x-intercepts of the graph. Okay? They are where the quadratic, where the parabola intersects the x-axis. Those are your solutions. So when you factor, you're basically finding where the graph is crossing the x-axis. All right? So we need to graph. Okay? We need to graph. Can you guys graph number 1?
Yeah.
Okay, let's graph number 1. All right. So, again, when you are solving, it's always going to be equal to 0, so don't use that when you're going through and graphing, okay? So when you're solving by graphing, you're still doing the same process. You're finding your axis of symmetry. So it's -b over 2a. What's b? 6. What's a?
1.
1. So that's -6 over 2. So my axis of symmetry is
-3.
-3. All right? Then we have to plug that in to get our y value. Be careful. It is a -3 that's being squared. So make sure that when you type it into your calculator, you include the parentheses. Otherwise, it's only going to square the 3 and then make it negative. So what is that? 9 minus 18 plus 8.
-1.
-1. So then my vertex is -3, -1. Now I make my table. Grab the parentheses there. What values did you plug in?
-2.
Our -2, our -4, -5, -1. You choose a side, give a few points, and then just copy them over. Okay? Let's use the smaller side. Let's go -2, -1, and let's go 0. When you plug in -2, what'd you get?
0.
0. -1
3.
and 0.
8.
Okay? So -2, 0. -1, 3, 0. 8's off. Okay. So for those who plugged in -4, did you get 0? And those who plugged in -5, did you get 3?
Yes.
You should have. They are symmetric. There we go. So your solutions are where the graph crossed the x-axis. Where do they cross the x-axis? So x equals -4, x equals -2. Those are your solutions to that quadratic. So once you graph, your answer, because it did ask you to solve, is x equals -4, x equals -2. So wherever the graph crosses the x-axis. Okay? That's how you solve by graphing. All right? Let's look at this one over here. We're going to look at this one together. Find the axis of symmetry. -b. What's b?
2.
Over 2a. What's a? -1. So that's -2 divided by a -2, which is 1. Now I need to plug 1 in to find my vertex. So plugging 1 in. See the difference? I'm squaring 1, then changing the sign. What is that? 0. So my vertex is at 1, 0. If I make a quick table, I'm going to take the shorter route. I'm going to plug in 0. 0 is always easy. When I plug in 0, I get -1. If I plug in -1, I'm going to write it out so everybody can see it. It's going to be a -1 minus 2 minus 1. That's a -4. 0, -1, -1, -4. And I'm just going to copy those points over. Should my parabola be pointing down?
Yes.
Why?
Because A is -1.
A is negative. Very good. What are my solutions?
Just 1.
It's just 1. X equals 1. Remember, the solutions are where your graph crosses the x-axis. So far, so good? Let's look at the next one. We are looking at these together because we are running short on time. So I want to make sure we get this because there's one more thing I want to show you. Yep. You notice how number 3 is not in standard form? You got to subtract it over. This could happen make sure it is in standard form. Make sure it's in the form of ax squared plus bx plus c. So you have to subtract the 4x over. Then we can do all the goods. Negative b, what's b? Over 2a, what's a? Negative 4 becomes a what? Positive 4 divided by 2, which is 2. Then I have to plug that into the function. Yes, plug it in to the one that is already equal to 0. When I plug that in, that is 2 squared, 4, minus 8, plus 7. And it's 3. So my vertex is at 2, 3. Is this going to point up or is it going to point down? It's going to point up. I'm going to choose 1 and 0. When I plug in 1, that's going to give me 4. When I plug in 0, that's going to give me 7. Then I just copy those points over. And when I mean copy those points over, I'm using the axis of symmetry to get the other side of the parabola. What are my solutions here?
0.
None. There's a difference between a 0 and then none. There are no real solutions. These are called imaginary solutions. That's a part of this unit as well, but we'll talk about that when we get there.
I have a question.
Yes.
Why was the 3 on the y side
Why was the 3 on the y side
instead of the x?
For this problem? Okay, so when we found the axis of symmetry, remember that's finding the x coordinate of your vertex. So 2 was our x value, so that's why we went over 2 on the x.
Okay.
And then we plugged it in, we got 3, that was the y. So that's why we went up 3. Yes?
So on a lot of these, like the majority of them, it goes from 1 and then it just goes out 1 and then 3 on like all of them.
Took my glory. Took my glory. Yes. There is a pattern with the points. Savannah noticed. Did anybody else notice the points? The pattern of the points? Still recording. Yes. Still recording. Yes. Anybody else notice the pattern of the points? No, it ain't 1, 3, 5, 7. Actually, is it 1? Yeah, it's 1, 3, 5, 7. No one noticed. No. Not one? Okay, let's go back then. Okay? Look at the very first one, right? Once we found the vertex, this point, the next point was up 1 over 1. The next one was up 3 over 1. The next one was up 5 over 1. Look at the next one. From the vertex, up 1 over 1, up 3 over 1. The next one probably would have been up 5 over 1. This one, up 1 over 1, up 3 over 1. So 1, 3, 5.
Will they all be like that?
The ones where A is 1, yes, they will all be like that. But when they're not 1, for example, like in number 3, instead of it going up 1, up 3, up 5, it's going to be up a half, up 3 halves, up 5 halves. Like you basically take those numbers and multiply them by the coefficient in the front. So this one here, the negative, instead of going up 1, up 3, up 5,
You'll be going down 1, down 3, down.
down 1, down 3, down 5. Does everybody see that?
A is 2, it's up 2, up 6.
Yep. If there's a coefficient in the front, then you multiply it. So like this last one, It's going to have you guys graph it out regularly, go through the pattern and show you for this one. It should go up 2, up 6. The next one's up 10, but that's clearly going to be out of our graph. Okay? Now, again, if you don't remember this pattern, you can always make a table. Your table is your safety net, okay, to getting the right points if you plug them in correctly. All right? So let's find the axis of symmetry real quick, the vertex, and then let's plot these points. All right? What's B?
-8.
So it's going to be -8, a negative 8 over 2 times
1. I'm at 2.
2. So that becomes 8 over,
4.
and what's 8 divided by 4? 2. Now we need to find the vertex, so I'm going to plug 2 back in. Please make sure you do your order of operations. You should do 2 squared, then times 2. What's 2 squared? Times 2? 8 times 2? So right now I have 8 minus 16 plus 6, which is -2. So my vertex is at 2, -2. Is this pointing up or is it pointing down?
Pointing up.
It's pointing up. Now remember, the pattern goes 1, 3, 5. But since there's a coefficient in the front, I should go up 2 over 1, up how many? 6. 1, 2, 3, 4, 5, 6. Over 1. That's where those points should be. But just to show you, I'm going to plug in 3 and I'm going to plug in 4 into my original function. So 3 squared is 9 times 2 is 18 minus 24 plus 6. What is that? It's 0. Wasn't that where that yellow point was? Plug in 4. Four squared is 16 times 2 is 32 minus 32 plus 6. Isn't that where that point is? So it works. That pattern works.
So the pattern's what?
1, 3, 5. But if A is something other than 1, you basically have to multiply those values by whatever A is. And it works every time. So copying them over, this point's here, this point's here. What are my solutions? 1 and 3. And this is how you graph a quadratic. You can always fall back on making a table if you forget everything that we've talked about, like finding the axis of symmetry, plugging in to find the vertex, the pattern. You can always fall back on making a table. All right? When you're looking for the solutions are what? Your x-intercepts, where it crosses the x-axis. Those are your solutions. If it ever asks you to find the zeros, no one asked me about this word right here. That also means x-intercepts, okay? That also means x-intercepts. Are there any questions?